Hi guys, this is Mrs. Millsap, and in this video we're going to be talking, in 4.1, we're going to be talking about electrons. We've learned that electrons don't exist in the nucleus of an atom, but they actually exist outside of the nucleus in this electron cloud area. That's what Ernest Rutherford said, that the electrons don't exist in this cloud. We now know that electrons don't just sit in a cloud, but they actually orbit the nucleus, okay? So they go around the nucleus in specific areas. We call those areas orbits. One thing that you may have heard in previous science classes is that your electron exists on this little ring and it just travels around the ring in the nucleus, basically orbiting in kind of like a planet around a sun. But that's not actually true. Electrons, they spin in unpredictable patterns, but they spin in a predictable area. So for example, this electron here, I know if he exists in this orbit that he is somewhere in this area, but it doesn't actually travel in a predictable way around the nucleus. In fact, what the electron does is it kind of spins like this in weird, unpredictable ways. All I know is that the electron at some given point in time can be found in this area, but it doesn't travel like a planet does around a sun in a predictable line. It just kind of goes and bounces around, but I know it's going to be in this specific area. And the way we know what areas electrons can be found in are based on their energies. So I'm going to move over here to this other picture. Electrons have different amounts of energy, so that's kind of our next point. We know that electrons don't spin in orbits. We know that they are sporadic, okay? They're sporadically bouncing around, but they sporadically bounce around in a certain area. So for example, electrons with lower energy are going to be spinning closer to the nucleus because they don't have as much energy to go away. Remember that the nucleus is positive and electrons are negative. What usually wants to happen between things that are opposite, positives and negatives? They attract, right? This electron, as it's spinning, is constantly attracted towards the nucleus, okay? But its energy continually gives it momentum, so it never actually crashes into the nucleus. It's just kind of held outside the nucleus, spinning around, but it's spinning around in an unpredictable pattern. So we're spinning around in an unpredictable pattern. I can never know where this electron is at any given moment in time, but I do know, because it's an electron that's closer to the nucleus, it has lower energy. So I know that electrons with lower energies will never be found on the outside. They're only going to be found on the nearer, closer to the nucleus. So here what I've drawn for you are 4 different energy levels, okay? And these energy levels are areas that we can find electrons based upon their energies. So the very first energy level is going to be for electrons with lower energies. And this outside energy level is going to be for electrons with higher energies. Okay, so electrons with lower energies are found in energy levels that are closer to the nucleus, and electrons with more energy are able to spin in areas that are further away from the nucleus. Okay, so now I'm going to move on down here. The next thing we're going to learn is that electrons, they don't have to stay in that area. They can actually move to a new energy level, but in order to do that, they either have to gain energy or release energy. So for example, an electron that is on this energy level can only have a certain amount of energy to exist on this energy level. If this electron were to gain energy somehow, then it would not exist in this energy level anymore. It would have to move and exist in a new energy level, okay? Kind of like when I take an object like this and I spin it around with just a little bit of energy, it's pretty close to my wrist, right? It's pretty close to the nucleus. What happens if I suddenly give my keys more energy? Is it closer to the nucleus or is it further away? I can see that it's further away because it has more energy now. Okay, I almost walked myself in the head like a couple times there. It was a close call. Okay, so how do electrons gain or release energy? They're going to gain or release energy in the form of what we know as light. Okay, so if this electron that's existing right now in this lower energy level, if it was to gain light energy, Then all of a sudden it has more energy. So guess what? It can't exist on its low energy orbit, energy level. It has to move now, jump upward onto a higher energy level. Okay, and it will exist there for a while. This process of an electron gaining light energy and moving to another energy level is called electron absorption. Okay, I'm going to give you the definition for that again. Electron absorption is when an electron is absorbing light energy and moving up to a new energy level, an energy level that's farther away. Electrons that gain energy and jump up can only exist there for a certain period of time. Eventually, that electron has to fall back down to its ground state, and when it falls back down to its ground state, guess what it has to do? It has to release that light energy that it kept. So when this electron falls back down, it will release light energy. So when it falls back down, it will release energy in the form of light. Okay, that's essentially how neon lights work. Is there are gases that are heated up, so the electrons jump to a new energy level, and as those electrons cool down or fall down, guess what they're releasing? Release from falling back down to their state. This process is called electron emission. So let me recap. Absorption is when light goes into an electron and it jumps up to a new energy level. Electron emission is when the electron that has, sorry, I can't write it. Okay, so when the electron has already jumped, okay, when this electron falls back down, it releases light. And when that electron releases light as it's falling back down, that's called electron emission. Okay, so now I'm going to go over some terms. This electron is jumping up and it's absorbing light. So this is called electron absorption. When the electron is in its regular energy state, that's called its ground state. So the regular energy level that the electron normally exists in is its ground state. When the electron gets excited or when it absorbs the light and it jumps up, that's called the excited state. So there's the ground state and the excited state. Absorption is when you go from the ground state and you jump to the excited state. Emission is the opposite. Emission is when the electron is in the excited state and it jumps back down to the ground state. Okay. So let's go ahead and look over here. These are the new, these are the new vocabulary terms that I just went over, and I want you to be able to define these. So at this time you can pause the video and you can write out the definitions to these words, to all of them except for the word photon. Photon is something that we're going to talk about in our next video, so don't define that. But go ahead and define the other 5 terms now on your page so that you can refer to them later. Okay, next we're going to talk about the nature of light. So light is weird. Okay, it doesn't exist just as a wave, and it doesn't exist just as a particle. So it actually has properties of waves, and it has a property like matter, like particles. So we call that the dual nature of light. So if I ever ask you a question on a test or a quiz, like explain the dual nature of light, you would just say that light has properties of a wave and has properties of a particle. That's why it's called dual, okay, because it's kind of got its foot in both campgrounds. So how is light like a wave? Well, light travels as an actual wave. It has something called wavelength, which is a characteristic of waves, and it has something called frequency. We're going to talk more about that later, but wavelength and frequency are both properties of waves. Light can also exist as a particle because when light travels, it can hit objects or matter, it can hit atoms, and it can move them. So it kind of acts like a particle because it acts as a force. It can push and move particles and travel. And so that's kind of why light is in both categories. In the next video, you're going to learn about what wavelength is and what frequency is. For right now, I just want you to know that wavelength corresponds with the energy of light. light that has high energy has really, really short wavelengths. So high energy equals low, or I should say short wavelengths. And wavelengths that are really, really long correspond with things that have low energy. So low energy and long wavelengths go together. So things that have a lot more energy have higher wavelengths. Things that have lower energy have lower wavelengths. This is another picture of the electromagnetic spectrum, but in this one we can actually see the visible spectrum here. And you can see red has a longer wavelength, violet has a shorter wavelength. So which one of these, violet or red, has more energy? Remember, longer wavelength means less energy. Longer wavelength means less. So that means red has lower energy and violet has higher energy. Okay, so what in the world does any of this have to do with electrons and their energy levels? Well, remember how I told you that when electrons fall, they emit light? That's really important because if an electron falls from a higher energy level, guess what? It's going to release higher energy light, right? Because it's at a higher energy level, and so it's falling down, it releases more energy than an electron falling down from a low energy level. That is releasing less energy, so the light that it emits as it falls from a low energy level is light that has less energy. So remember, we just talked about how the different colors of light have different energies. So we should be able to identify what energy levels will release different colors of light. For example, if an electron fell from a lower energy level, that means they're releasing low energy light. We know that red is low energy and violet is higher energy. Now, how do we know that? The way we know that is because I just told you that longer wavelengths correspond with low energy and shorter wavelengths correspond with higher energy. Violet has a shorter wavelength, so it has higher energy. Red has a longer wavelength, so it has lower energy. So electrons falling from a low energy level are probably releasing red, orange, and yellow light when they fall down, right? Because those are all lower energies. However, if I have an electron that is falling from a higher energy level, it's going to be releasing light that's higher energy. So things like violet, indigo, and blue are going to be released from an electron falling from a higher energy level. That's really important because when we heat up atoms, we can heat them up, and when we heat them up, sometimes we see colors. And the colors we see are the electrons falling. So that leads us to our last bit of new vocabulary, and that's spectral lines and emission spectrum. Spectral lines are the colors that are emitted from the electrons at different energy levels. Spectral lines act as a fingerprint for an element. Each element on the periodic table has a different spectral line, okay? And again, let me tell you what spectral lines are. They are color lines that tell us the energy of the electrons that are falling. So I know when I'm looking at this fingerprint or this element, I know that I have this is an electron that's falling from a low energy level. And then here I know that there's electrons falling from high energy levels. And every single atom has different energy levels and electrons that fill up different energy levels. And so this spectral line is like the only one for that particular element. Let's look at some examples. This shows you the spectral lines for helium and neon. Helium, you can see, has a different spectral line than neon does. That's because helium and neon have different protons, and so they have different numbers of electrons. So what you need to know is that each of these lines represents an energy level. We know that these are lower energy levels because things with red light have lower energies. These are higher energy levels because we know that light that's violet and blue and indigo are higher energy light. Okay. Well, what can we do with this knowledge? Well, one of the things that we're going to do in the lab is I'm going to give you an unknown sample with spectral lines, and you're going to have to figure out which elements are a part of this unknown sample. Well, how do we do that? Well, what we want to know is that this unknown sample is a mixture of two of the elements below. Which of the elements below will be, if I put them together, would make up the unknown sample? I know it can't be element A because element A has a line here, and that line is not present in the unknown sample, so it can't be element A. And also, element A doesn't have this line in the unknown sample. However, if we look at element B could be in the unknown sample because this line is in the unknown sample and this line is in the unknown sample. Let's look at element C. Element C could also be in the unknown sample because this line is in the unknown sample, this line is in the unknown sample, and then the two middle lines right here are also in the unknown sample. We know it can't be element D because element D has several lines right here that are not present in the unknown sample. So that means my unknown sample must be a mixture of B and C. Okay, that is it for your 4.1 video. Please make sure that you go back and you have definitions for each of your vocabulary terms, and you may begin the challenge. That is it, and have a fantastic day.